Hey guys, welcome to the channel, and in this video I will be explaining you one question from tree series of an interviewBit. So this question is basically we are given a binary tree and we need to find out whether it is a mirror of itself. Mirror of itself means whether this is symmetric or not. So if I have given this binary tree, if I take mirror of this, I will got this as an output. Okay, so as you can see, the mirror of this tree is that only which is symmetric. So this is a symmetric binary tree. Likewise, if we take this is as our input, if we take mirror of this, then we will not find out the same tree which we have earlier. As you can see, we will find out this as our tree. So this is not symmetric to this tree. So this is an example of non-symmetric binary tree. This is an example of symmetric binary tree. So we have to write a code which will find out whether the given binary tree is symmetric or not. So now let's see how to solve this question. If we take an example which I have showed you earlier also, if we have this example, let's say 1 2 2 4 3 3 and 4. If this is the example which is given to us, what we need to check is we will first call this function with let's say if our function is r, which is recurse, we will pass this function as root left and root right. So this function is called from the main function. Okay, so first function call is this. When this function call is encountered, root left is 2, this one, and root right is also 2. So we need to check some base cases here. Okay, the base cases is, suppose if root left is null or root right is null or not, it's AND. If both is null, then we need not check further, so from there we will return this function call. If this is not the case, if let's say root left is not equal to, or let's say is equal to null, and root right is not equal to null. So this is the case where there is no element present in the left of the root, but there is element present in the right of the root. So when we take the mirror of that, let's say if we have this, there is no left child, it is null, there is a right child. So if we take mirror of this, we will got this. So this is not a symmetric case. So in this case, we will update our flag which will contain our answer to false and return. Okay. Likewise, we need to check one more condition, that if there exists any case, let's say where there is a left child but there is no right child. So likewise, in this case also, if we take mirror of this, then this is also not symmetric. So in this case also, we have to return flag as false and return from here. So these are the base cases. Likewise, we need to check one more base condition, where we need to check that if root left value is not equal to root right value. See, if we have, let's say, tree as 1 2 3, if we take mirror of this, then we will got 1 3 2. So as you can see, this is not symmetric case because the values are different. So in this case also, we need to return flag as false. So these are some of the base conditions which we need to check, and if all these base condition fails, then we need to recurse the function. We need to recurse the function where we have, let's say, this root left is, let's say, L, and this root right, say, R in our function. Then we will need to recurse L left and R right. Likewise, there is one more recursive call function after this, that is R left and L right. So these two recursive calls we need to do in this our main recursive function. So why these two recursive calls? Because when we are at here, then let's say not here, when we are at here, this is our L, this is our R as per this function call, initial function call. So next we need to check this 4 with this 4, because when we take mirror of this 4 will shift here, this 4 will shift here. So we will pass L to left here, L to left, likewise R to right, because we need to check these two cases now. Likewise, we will take R to left, that is these three element, and L to right, these three elements. So we need to check these two elements. So as you can see, we need to check these alternating elements. Likewise, if I take one more example, let's say if we have 1 2 2 4 5 3 and 3. So in this case, what we need to do, initially we are at L is here, R is here, so we need to check L to left with R to right, L to left with R to right. So 4 is not equal to 5, so in this case we will simply return false from here. As you can see, when we take mirror of this, we got mirror as 1 2 2 5 3 3 4. So as you can see, this is not the mirror, so this will this will not follow our symmetric condition. So this is pretty straightforward question. So I will show you the code for the same now. The code is exactly same which I have explained you in the example. See what we have passed from the main function, we have taken one variable flag which will hold whether the particular tree is symmetric or not. If A is null, suppose there is no element in the tree, then we will simply return the flag, because that is symmetric only if there is no element. Likewise, if we have, let's say, this as our tree, then we will first pass L and R as this, that is A to left and A to right. Along with that, we are passing flag as an reference, because we will update flag as per our condition checks. So this is the first base condition which I explained you, that if any one of this is null, then we will simply return from here. If both is null, then we will simply return from here. This is the AND symbol. Okay. This is the second base condition, where if any one of them is null and other is not null, then we will simply need to return from here. The cases in this case are, let's say this is our graph or this is our graph. So in this case, we will simply update our flag with false and return from here. The third condition, base condition, we need to check is if the value is same or different. In this case, let's say the value is different. So in this case also, we will update our flag with false and return from here. And these are the recursive function call which we need to do for traversing all the nodes of the binary tree. So hope this question is clear to you. If it is not understand, then please drop down the comment and I will happy to help you. So let's try to compile this code. I have submitted the code. Now let's see if it's successful or not. Yes, it's successful. So this question is pretty straightforward. So hope you got it. Thank you.